Today I'm going to demonstrate subnetting concept with a case. For example, ABC is an organization which is having three different offices. One is in north. This particular region is north region, and this particular region is east region, and this particular region is west region, and they have given a class B IP address 172.16.0.0/16. This particular class B IP address you need to do subnetting. Now they have given few specification. First they are telling that this 172.16.0.0, this is the entire network of this organization. This will be subnetted as follows. The subnetting, initially this has to be equally, this number of hosts need to be equally divided into three zones, that is north, south and east. North, east and west. Okay, now each and every region, if you check that each and every region, north region is having 4 LAN. This is LAN 1, LAN 2, LAN 3, LAN 4, and then there will be another requirement that you have to further subnetting this particular IP addresses into 4 more subnets. So there are few golden rules. For example, if I take 172.16.0.0, this particular network, this is class B network. So if I see class B network, the default subnet mask is 255.255.0.0, because the reason is, the rule says how many bits are there in network. The network bits all set to 1 and host bit all set to 0. So here the network bit is 16 bit and equal, host bit also is 16 bit. So since first 16 bit is set to 1, this is 255.255.255.255.0.0. So we need to concentrate on this 16 bit, because we have to actually do subnetting depending on this particular 16 bit. If I see the CIDR notation, I write this as class 16. That means the first 16 bit is fixed, means you don't have to think about first 16 bit. Later 16 bit you have to work out. Now first I have to create 3 subnets. We cannot create because it is all 2 to the power. So here in this case, if I look into this 3 networks, I have to create 3 subnets. So I cannot create 2 to the power 2 equal to 4. I have to create 4 subnets. So if I want to create 4 subnets, I have to borrow 2 bits. That's the rule. I have to borrow 2 bits. Okay, so this is 16 bit, this is network. So from this particular host bit 16 bit, I have to borrow 2 bit. So that means it has to be /18. So all those subnets in this 3 region, okay, so this will be /18, this will be /18, and this will be /18 as well. How to calculate? What do I mean by /18? From /16 to /18, what do I mean by that? Okay, let's calculate. So /16 means 16 bit will be set to 0, sorry, set to 1. Now slash 18 means 18 bit will set to 1. So this is my subnet mask. Now here in this case I will be getting a different subnet mask, that is called VLSM. So I'm giving you a VLSM calculator so that you can actually easily calculate VLSM, variable and subnet mask. Please go through this particular. Okay, if you look into the IP addressing, I have the entire 32-bit block divided into 4 8-bit blocks. Okay, so if you look into the 4 8-bit block, this is 8-bit, this is 8-bit, this is 8-bit, this is 8-bit. So if all 8 bits set to 0, for example slash 16 means 8 bit set to 1, 8 bit set to 1, and this 8 bit set to 0, this 8 bit set to 0. So 8 bit set to 1 means it will be 255, and 8 bit set to 0 means it is 0. If in between, then I have to calculate, means if it is 0, then the value will be 0. If it is 1, then it will be 128. I am giving you the calculator. How I am getting it? Because if you look into this particular table, I am just showing you the table. If you look into this particular, okay, bitwise value, this is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. So 2 to the power 7 means 128. This will be 64. So if one bit is set to 1 and remaining all bit are 0, so it will be 128. So in that way, if it is 1 1 and remaining all bit 0, 128 plus 64, it will be 192. So it will be 192. 3 means it will be 224. If you add 32 more, it will be 240. Then 5 bit, this has to be 248. If it is 6 bit, it has to be 252. If it is 7 bit, it has to be 254. If it is 8 bit, it has to be 255. Now from this calculator, if I calculate what will be 18 bit, then it will be, you have to take 8 bit maximum. Okay, 8 bit, then 8 bit, then 2 bit, 8 8 16 plus 2 bit, then 0. Now you can see the VLSM will be 255 255. 2 means 192 and 0 means 0. So it has to be 255 255 192.0. So let me show you another calculation, the block size. So what is block size? For example, if it is 2 to the power 8, the entire 8-bit block, there can be 256 numbers, which will be 0 to 255. So now here in this case, okay, if it is 192, so in that particular block, how many numbers will be there? It is very easy. 256 minus 192, it has to be 64. Okay, so another way, when we calculate subnets, okay, it is very easy to calculate the subnets. Now I have to calculate the subnets. So if it is slash 18, from slash 16 to slash 18, I have borrowed 2 bits. So I will be getting 4 networks. I will be getting, okay, the subnetting is, I have to get different subnetworks. So this was a network which will be divided into, I require 3 subnetworks, but I have to calculate 4 subnetworks. So I will be getting 4 subnetworks. So I am calculating 4 subnets. To calculate subnets, I have to okay, consider this particular network. So in this particular network, I will be getting 4 subnets of /18. So these are I will show you how I am getting it. These are 0.0, 64.0, 128.0 and 196.0. Now please understand how I am getting it. Okay, so it was 172.16, forget about this, 0.0. Now if you look into the 8-bit, okay, the first 2-bit will be now in network portion. So this 2-bit, if it is varying, okay, what are the numbers I can get? 0 0 1 0, sorry, 0 0 0 1 1 0 1 1. If it is 0 0, then it has to be 0.0. If it is 0.1, that means this value is 0, this value is 64, remaining all are 0, so it has to be 64.0. If it is 1 0, then what will be the value? It has to be, this bit is 128 and remaining all are 0, so it will be 128.0. and if it is 1 1, say, so it will be 192. And you can see the magic number 192, that is subnet. When I was calculating VLSM, variable length subnet mask, in VLSM variable length subnet mask, I was getting the value as 255.255.192.0. this 192 I was getting by setting 2 bit 1 and remaining all 1 2 3 4 5 6 bit 0. So this value is 192. Here in this case also you can see, when I am getting 0 1 0 0 1 0 1 1, this 4 subnets, in case of this 4 subnets, the values will be multiple of 64. That is what I was calculating block size. So how many subnets? I have borrowed 2 bits, so 2 to the power 2 equal to 4. I am showing you the magic number, so it will be 0 1 2 3. So multiply 64, the block size, into 64 into 0, it is 0, 64 into 1, it is 64, 64 into 2, it is 128, 64 into 3, it is 192, and that is how I got 4 subnets. Okay, 0.0, 64.0, 128.0, 196.0. Now these are my different zone. If I look into this zone, this is not zone, so any number you can take. Okay, so here in this case you will be getting 4 different zone. Now you have to choose what are the IP addresses, what are the subnets you will be using. So for example, I am using /0.0/18 here in this case. So this subnets I can consider this particular subnet here.